Hey everybody, today I'm going to show you how to build a JavaScript widget and serve it up as a web page in less than a couple hundred lines of code. And uh, give a really quick demo and then go deeper once I get into the code a bit. This widget is actually being hosted by GitHub using GitHub Pages. Um, you see that the first view is basically an addition table. I can move the cursor over to 7, go up 3, and I can see from the intercepts 3 and 7 that those add together to 10. I hit spacebar. I could have hit the toggle view button. The next pane shows a sort of like an abstract geometric sequence. We start at it's being a little sluggish. We start at R0 and then we can go to R1, R2, R3, R4, and we could show that, for example, R to the 7th is the same thing as R cubed times R to the 4th. Now I hit the toggle view button. I see powers of 2. Notice it kind of keeps me in the same place. And I can see that 16 times 8 is 128. And then I go to the final view, which is Fibonacci matrices, which are a little hard to see, but I go from the where am I? Yeah, the identity matrix to the special matrix. Let me click on that. 0, 1, 1, 1. Then I go to 1, 1, 1, 2. Now I'll start to use the arrow keys, and I'm basically progressing through the Fibonacci sequence. Let me make this a little bigger for everybody. Yeah, 8, 13, 21, those are all Fibonacci numbers. But I'll explain that when I get into the code a little more. Again, I can hit the spacebar just to kind of keep toggling through all these different views. So let's go to the code. So I'm going to click on the code. It takes me to the web page. Real quickly, the license is the so-called unlicensed. And it basically means this free and unencumbered software released into the public domain. There's a README and it says see the live demo here. So if I click on that, we're right back to where we started. And then the index.html file. It's 14 lines long. We have the doc type to tell the browser that it's HTML. You don't really need that because that's what it would assume. I've got the head section with the title, and the title up here is Algebra Widget, and that only surfaces, at least visually, in the browser as the name of the tab. And then I've got the body, and this has a little bit of boilerplate. You can see here this is the button that actually opened up the code. So that's that. And then we've got the toggle view button, that. And then we've got this span ID called mode title. And you notice that it's not filled in because most of the HTML will get built out by the JavaScript code. But that's this section right here where it says sum of integers, geometric sequence, powers of 2, Fibonacci matrices. I've got an HR tag. Hopefully you know what that is. And then again, I'm only putting the structure. So I have a table called main grid, but nothing's filled in the table. That comes with JavaScript. And by the way, this status and flash, those are relics of me copying and pasting from another app, so they're not even used. And then finally down at the end, I embed the fib.js script. So let me show you that, because that's where most of the application magic happens. All right, and so here I am. Let me give you guys a slightly bigger font. Okay, it's 311 lines long. I have these two constants, n and m, and what they do is they set the width of the viewport. So if I hit the home key, I go back to my original view of this particular view. Like if I go into geometric sequence, come up here. In fact, let's even scroll it down into negative powers. You know, by the time I get down here, I can't even see the the x-axis. So if I hit home, it takes me back to the origin, but I'm still in this pane. But anyway, this viewport, what we're looking at here is just an HTML table, and the dimensions are 15 by 15. Obviously, since it's a square now, I could have used one constant, but I've been tweaking this here and there. Then I have a mode that says that this is arithmetic mode. And then I have the current location, and that's just going to refer to wherever this cyan cursor is. And we'll see the structure of that later. I have this function called show mode that, based on the mode, shows me the label. So hopefully that's very straightforward. I have a toggle mode function that basically says if I'm in arithmetic, go to geometric. If I'm in geometric, go to power 2. Power 2, go to fib. Otherwise, go back to the beginning. There are obviously fancier ways to do this, but I chose the simplest possible way for me to understand. And then I start having functions to fill in the boxes. So arithmetic means the arithmetic sequence. I don't remember whether I call it that. Well, sums of integers. These are based on the most basic arithmetic sequence known to man, which is 0 plus 1 is 1, plus another 1 is 2, plus another 1 is 3, plus another 1 is 4. So for arithmetic, when I fill in the box based on n, I literally just return n, and I stringify it. And the geometric, for the geometric function, again, all I'm doing is saying r to the n using the sup tag. I forget what sup example, superfix? I forget what that stands for. But you can see its effect here. And then powers of 2. Again, I'm not actually computing well, I am doing a little bit of computation here. But I'm really producing labels for pretty simple things. So if n is less than 0, then I notate that as 1 over 2 to the power to the minus n. Where again, because it's less than 0, this is a positive power. I'll show you that here, and I have to go backwards a little bit. Yeah. So like, for example, 1/128 is the product of 1 over 1024 times 8. All right, and then we get to Fibonacci. So Fibonacci is a little more interesting. First of all, I have a cache because I'm doing the recursive version of the Fibonacci sequence. It's very important when you do recursion that you don't keep calculating the values over and over again. But the way calcfib works is if n is 0, return 0. If n is 1, return 1. The negative case is a little interesting because then we kind of calculate, we do the Fibonacci calculation in reverse. For the positive case, you say that a positive number is the sum of the previous two numbers. A negative number is the difference of the two bigger numbers. And then this is obviously extremely important. If the value of n is already in the cache, I return it right away and I don't do any recalculation. But then here's the classic recursive solution for positive Fibonacci's, and make very sure to put it in the cache. All right, and then that calculates a single Fibonacci number. If we go back to the widget, and again, let me expand these. If we go back to the widget, every square is basically a matrix based on three successive Fibonacci numbers. And I basically build them with a little inline table. And you can see I calculate the nth Fibonacci as the top right. I also put that in the bottom left. And the top left is the previous Fibonacci. The bottom right is the next Fibonacci relative to n. And you want to avoid interpolating certain things into strings, but I know that these are numbers, and I know that this application has 0 user input, so there aren't any big security concerns. Then I have this helper called makeLoc, All it does is take an XY value and it bundles them into a little tiny structure. And that's relevant because up at the top, I told you we're going to store the current location of this. Let me go to the next screen here. This little cyan cursor. That location is represented by a structure that looks like this. Okay, and then I start having all these functions, these little helper functions that, given a location, tell me, am I the current location? Hopefully these are pretty self-explanatory. If I'm asking if this location is the current location, that means both the x value and the y value have to match. In order to get an x-intercept, I have to match on the x values, and then y has to be 0. And these intercept calculations have to do with these blue-violet things here. Let me get out of negative numbers just to remove one distraction. So the cyan is on 12 here, and 12 is 8 and 4, and those are the intercepts along these quote-unquote axes. Okay, so and then is y-intercept location works very similar. Is intercept location is just the order of those two. Is axis location means that either the x value is 0 or the y value is 0. And that corresponds to this sort of brick reddish color. I'll find out what color it is in a sec because we're getting there in the code. And then is origin, pretty self-explanatory. Is diagonal says that the location of x has to either equal the positive value of x or the negative value of x. And if you remember how to graph y equals x in high school, this is like where x equals y, and it's in this very subtle pinkish color. And this is where x equals negative y, and again in the same color. And it's kind of important to show both of these. Let me go to the next view. Along this diagonal, you have all the perfect squares of R. And along this diagonal, you have all the basically unity elements of this sequence, the first elements of this sequence. So every now and then you can kind of get lost in the maze of all of these R cube, R4, R to the 7th, and this can help you orient you. Especially if you start scrolling off screen a little bit. All right. So get location colors next. You pass in a location on the grid, and then it returns the color. Hopefully this code's pretty straightforward. These are all built-in CS colors. I just Googled for CS colors and looked at some colors. Those were the ones I liked. And then in order to get the square contents, this line here is kind of subtle, but what's happening in all of these widgets is that underlying, let's see, what's the best way to show this? It's probably best showing the integers. Again, I'm going to hit the home key. Go back here. Let's see. So all of these sequences are kind of like shifted over one from the other. So we have 0 onto 15, 1 onto 16, 2 onto 17. And kind of in order to make that happen so that these values along this diagonal are all equal to each other. In fact, I can show you sort of that a little more intuitively. So 11, 11, 11, 11, 11, 11, 11, so on and so forth. Anyway, I determine what value I want to have at a particular position, and then based on the mode, I call one of these functions that I showed you earlier. The arithmetic, the geometric, the power 2, or the fib. And I can scroll up there pretty quickly. So here's fib, where I was telling you it builds out that little square matrix. And then the geometric, for example, uses the subtag. And it's bugging me that I can't remember what exactly. Oh, superscript. Superscript, duh. Okay. I think that's what it's short for. Superscript tag, again, is what makes the superscript. I guess I'll show you the cyan one right there. Anyway, going back down to where I was, yeah, based on the location, I set a certain color. We'll see how that's called later. And then, oh yeah, and based on the contents, I compute a certain value. That's where I was. And then we start having code that's really just styling widgets. So in order to add table styles, if I pass in a table, I forget what they call this, an element, I guess, when you're using pure JavaScript. An element, every HTML element has a built-in style thing, attribute, and you can set the border. So I set the border to blue, border collapse to collapse. You can see the blue borders here. And then when I draw a normal square, I call get location color. And again, I showed you the implementation for that just a few seconds ago. But after I get the response back from that, I set that as the background color, set the font size, and then I set the inner HTML of the table to be equal to the square contents. And again, for the square contents, I showed you that function. It's just calling one of these 4 functions based on the mode. All right, and then I have a function to make a cell. So whenever I make a cell, and a cell is what you think it is, it's that cyan thing, that's a single cell in the table. I call document create element, and again, I'm doing this all in pure JavaScript, so I'm just using kind of the built-in API for constructing HTML. So I create an element of TD, I set its ID to whatever's passed in, and I'll show you that code in a little while. I set the height, the width, the border of the TD here, not to be confused with how I set the border of the table itself, but of course I want those values in most cases to be the same. Then I have a redraw board here, board function, and you'll notice that this code appears to be upside down in 2 ways. Normally, like if you have a nested loop, you would loop X on the outside, Y on the inside. And of course here I also loop, I'm misremembering. Okay, the loops are actually in a very natural order because I do use Cartesian sort of, what's the word for it? Geometry, but that's not the word I'm looking for. But anyway, so what I'm doing here is I'm going from y equals 0 down to what was it, n, and then from x from 0 to m, and I'm building the I'm building up an ID, and this is important. So the ID of the table data is going to be the x coordinate separated from the y coordinate with a comma. And I'm not remembering why I need to get the document. Oh, okay, because this is the redraw, right. So by the time I call redraw board, I will have already made the board. So in order to fill in values in the board, I call get element by ID, using this ID to find the table data that I want to draw. And again, I think I just showed you draw a normal square. Yes, I did. And I also make this location. And now this is another minorly subtle piece of code. So let me show you something here. Let me inspect this cell. So the ID of this cell here is 4, 5, which makes sense. Let's see, I think it's 4, 5. Yeah, which makes, actually, let me highlight that. Sorry, this is clumsy. So let's see. Zero, 5. Let's see. Okay, here we go. So the currently selected cell is ID 4, 5, which makes sense because R4 times R5 is R9. This is x coordinate 4, y coordinate 5, both semantically, and also in terms of where the viewport is. But let me get out of the inspector. Let's say that I start scrolling down into negative values. ID of this table cell is not going to be 12 comma 4. It is going to be 4 comma 0. So if I inspect that, yeah, you can see here that it's 4 comma 0. So that refers to the physical geometry, but not to the semantic geometry. Apologies if you don't, if you know that this is just obviously a viewport calculation, but I make the location, so I have to take the actual x value and subtract off the offset, and that is why up at the top I initialize the offset, and we'll see later how that offset gets changed by code. But if I reload the app, well, actually, this is the original location. Well, if I reload the app, then you can see that the physical coordinates and the semantic coordinates are the same thing. So let's see. Let's go back down to where I was. Yeah, I hadn't gotten them making the board yet. All right, so we're getting to the finish line here. And then I draw it. So the redraw board is responsible. So anytime I basically do anything, but particularly like move a cursor, instead of like, let's say I move the cyan from 10 to 11, I literally just refill every single square. I don't try to be smart by saying, well, if I move from 10 to 11, I need to make 10 white and then 11 cyan, because that would create a lot of unnecessary code complexity. And let me turn off the inspector. Like certainly here I'm redrawing everything, redraw everything. And if I move pretty quickly through, redraws are happening on almost every step here. It's not a concern for a widget this small. Okay, handle square click. That's really simple code. If I click on a square, then I reset the current location. And again, current location's initialized. Well, it's sort of initialized at the top. It's actually initialized way at the bottom. Actually initialized down here. But yeah, I just reset that value and then I redraw the board. And the advantage of a strategy where you just redraw everything at once is that all the underlying functions from redraw board will just do the right thing. Here's where I actually set up the click handler for a TD. So I say TD on click. Okay, here again we get into offset-based calculations. So I get the ID of the TD element, and that always stays fixed. That is always like the physical location within the table. I split out X and Y, and then I subtract off the offsets to get this location that is the logical location within the grid. So, if the offset is big enough, that means that the value of X after this calculation may be negative. And again, like a negative X would correspond to me the cursor like way over here. And again, I can hit home to get everything back. All right. And okay, and then there's a function to make the board. And again, I explained earlier that the index.html just has this skeleton with the table of the main grid. So let me show you that again real quickly. Yeah, that was here. Remember I told you that the table wasn't filled in yet? Okay. And sorry, I lost my place. Yeah, so I get that table. I said it's children of 0. I have a doubly nested loop. I use create element to create the TR in the outer loop, and then in the inner loop, I loop over all the values of X. I construct these IDs. I call make cell, which you saw earlier. I call set click handler, which you saw earlier. Then I append the TD to the TR using append child. This is a built-in browser thing. And then out of the inner loop, but out of the inner loop, but inside the outer loop, I call append child. And then finally, I call add table styles. And I showed you that code earlier. I have this toggle function, which all it does is toggle mode and redraw the board. And if you remember, let's see, where was it? Well, I'll show you what it does. Obviously, you know by now that it's basically doing this. Toggle mode is the one I meant to select here. That's why I was confused. Toggle mode was this function that I said could have been a little fancier. Anyway, that's what toggle does. Okay, and then I start having a whole bunch of functions that allow me to do motion. So I've talked about home several times and I've demonstrated it. I'll demonstrate it one more time. Say I come here, down there, and now I'm in no man's land. I hit home and boom, I'm right back. The code to implement that is literally 4 lines of code. I say current location is make look 0, 0, and my x and y offsets are 0, and then I redraw the board. See, I'll come back to increment y, high level, increment y, decrement x, increment x are all very simple motion keys, and they support the motion. They're very simple movement functions that are all backed by moving the arrow keys. And the one subtle thing that you have to do is that if you run out of real estate, then we have to change the offset of the viewport. So in the increment y function, for example, which would be called by, actually, let me show you the one that we actually encountered, decrement y. Oh, no, I was incrementing y. The logical value of y, when I hit up, here I am at the top. I'm going to increase this from 17 to 18, what the y coordinate is, and I run out of real estate, so I have to adjust the offset of the viewport. When that happens, first of all, I just make the new location, the new current location 1 up regardless. But then if I see that takes me off the screen, then I call offset y, and then I redraw the board. And then those 4 functions all work the same thing, or all do the same thing. Let's see, set reset handler. Oh, okay. This is a little copy paste error. I should have renamed that to set toggle handler. You can see I copy pasted from an app that had some sort of reset button. But all I'm doing is I'm saying that the toggle button, it says reset button again, copy paste, is get element by ID from toggle, and then I say its onClick method is toggle, and I achieve that renaming successfully up here. And then let's see. Okay, and then I set the keyboard handler. I'm not going to dive too deep on this because this is a pretty standard keyboard handler, but you have this document add event listener for the key down, get an event, and then I just inspect all the keys and call the appropriate methods. So for example, arrow left, I call decrement x, and for arrow right, I call increment x. And then down here, we're almost done, folks. We say that this happens, at module scope. So it happens when we load up the module. The current location is 0, 0. I show the mode, which again is up here. I make the board, and then I immediately redraw the board to kind of fill in the board. I should probably just call that fill in board. That would be a better name for that. Again, set reset handler. I need to rename that to set toggle handler. And then finally set keyboard handler. And that's the entire app. And I guess I'll go really quickly to show you why this is hosted on GitHub IO with me almost doing nothing. Obviously, there's a little bit of work to upload code to GitHub. I assume most of my audience knows how to do that. And if you already know how GitHub Pages works, you can probably cut off here. Thanks for listening. But in order to serve up something on GitHub, I follow the convention that index.html, which again I had showed you earlier, I follow the convention that my top level file should be called index.html. And when you go into settings, for the and I'm in the context of the repo, then you can go down to pages, GitHub pages. So you can see that the site's hosted live. And I'm not going to belabor this too much because there are good tutorials both from GitHub itself and like YouTube contributors on how to do that. So I'll stop here, everybody. This is going to be part of my Fibonacci series, even though I didn't really explain what I'm doing. Sorry. I didn't. Why is it doing that? It's weird. Yeah, I didn't really explain the purpose of this, but I'll do that in a future video. Anyway, thanks for listening. Bye.